Hi, today we are going to discuss exponents, square roots, order of operations, and scientific notation. So for the very first thing, definition for exponents. For any counting number n, that is going to be positive number n, b to the nth power equals however many b is there. B to the nth power as the power. B to the n as the power, that means the nth power of b, or b raised to the nth power. Either one will be b to the nth power right there. B is the base and n is the exponent. B is the bottom, so therefore it's the base, and then n is the little number, which is the exponent. So in this case, we already did a lot of this kind of problem before, but we're going to review it one more time real quick. This is 5 to the 4th power. It technically is really just 5 times 5 4 times, and that is going to be 625, or you can punch in the calculator. Now right here you have to understand, is it in a parenthesis or not? That's very important. In this case, it's just going to be -9. The next one is going to be example 3. It's -3 in parenthesis. Here's the parenthesis, very important. -3 is inside the parenthesis square, and so therefore that's -3 times -3, and that's going to be +9. So there's the difference between the +9 and the -9. Please make sure that you realize the difference. And this is 625. Then what you have here is going to be the 4/5 to the 3rd power. And that's just from before, is 4 to the 3rd power and 5 to the 3rd power. And that is just going to be 64 over 125. For the next thing, definition of zero exponents. Definition says, for non-zero b to the 0 power is 1. Anything to the 0 power is 1. Right here, what you have is 3 to the 0 power is 1. Parenthesis 2/5 to the 0 power 1. Even when you have things look like parenthesis to the 0 power, as long as they are in the parenthesis, the 0 is attached to whatever is next to it. That whole part is 1. So anything to the 0 power is 1. Going on to the next rule. Negative integer exponents. If n is a counting number, again 1, 2, 3, 4, 5, and so on, and b is non-zero, which could be anything except 0, then b to the -n power. That negative symbol right here tells you to flip the top to the bottom. So in this case, b to the kind of like over 1. And then you do a flip. Please recognize the negative sign is gone. So become a positive n. So let's try some example. You have 5 to the -2 power. So when you flip it over, this is like over 1. So it's 1 over 5 to the 2nd power. Notice my negative sign is gone. And that's equal to 1 over 25. And that's your answer for that problem. And the next one, please try yourself. The next example, the answer is 1 over 10 to the 4th. Flip it over, and that's 1 over 10,000. Then the next thing we're going to talk about is the principle of square rules. The principle of a square root is going to be, if a is a non-negative, that means underneath, that means no negative numbers, then square root a is non-negative number we square to get an a. Is the non-negative number, which is that number we're going to get, it's going to be a positive number, we will square. That means what number times what number will give me the a, and they both have to be positive. That's what non-negative means. We will call square root a principal square root of a. Going on, few rules. Rules are inverse of exponents. So there's all kind of rules that inverse, that means cancel out each other. And here's the very first one. A square root is usually the very basic we talk about. That means you have that little 2 in the front that we never seen, but it's there. It's the inverse of square. Square is to the 2nd power. So square root and square cancel each other out. We write both positive and negative answers in a compact fraction like this. Positive -5. So when you have a square root of x, and if you square it, that will cancel each other out, and your answer will be x. And that is your example. Then there's a couple names. You have the name of radical, which is a little square root, and the radicand is the number underneath, which is the 25. The principal square roots is going to be the 5. So 5 times 5 gives you 25, and that's what the information talking about. We call the square root the principal square root of a. Principal square root is 5, and and therefore square root of a is going to be 2a times a gives you the square root 20. Going on to the next thing, we're going to evaluate our square roots. Rules for square roots. Every positive number, there are two square roots, a positive root and a negative root, and that's for solving. So negative number have no real number square root. So what we're going to do is we are solving the next equation. And if you solve equation number, example number 5, square right here is cancel out with the square root that leave you with the x, and so you just square root both sides, and x is going to equal to positive and negative 3. And the reason it's a positive negative 3 is you can have 3 times 3 equals 9, but negative 3 times negative 3 also equals 9, and that's why you can have two answers. Example number 7, if we square root both sides, because that's how you cancel it, x is going to be not possible right now because it has a negative sign underneath the square root. Therefore, this is not possible. Now, here's the next set of information. It says find the square root right here. Find the square root. Now, understand this does not have an equal to x. So we are only looking for numbers that multiply give you 49. And the 49 is going to be positive. This case, that is just going to be 7. And the next one is just going to be square root of negative 49. We're going to say that's not possible. Next one, we have a negative sign outside of the square root. Now, the negative sign outside the square root tells you don't do anything because order of operation, square root is like the parenthesis. Handle my square root 49 first. So when I handle it, that's going to be just negative. Square root 49 is just going to be 7. And that will be your answer. The last question, that's not going to be possible because handle the square root first. And when you handle the square root first right here, that is not going to be possible. So therefore, and do not get careless, a negative times negative become positive because you're supposed to handle everything inside the square root first. Rule square roots involving radical signs. So the radical symbol denotes only the positive principal square root. So they are talking about only positive. So once they are positive, couple things can happen. Follow the rules. If you have a square root over the whole thing, you can split it up. So square root a on top, square root b on the bottom. Where a is got to be positive, bigger than 0, and b has to be also positive, bigger than 0. B definitely cannot be 0 in the denominator. Okay, so for this example, we can actually split up the square root 49 and square root 81. And very simply, we can just say square root 49 is 7 and square root 81 is 9 for this example. Approximating the square roots, you are going to take a rational number is a number that can be written in the form n over d, a rational number. Rational number means there's a pattern. The decimal terminates. So going on where n and d are integers and d is non-zero. Again, d cannot equal 0 because it's in the denominator. And then n is an integer, not fractions or anything like that, integer. So n can only be positive, negative, and 0. Going on to the next thing. So in this case, when we talk about perfect square, approximating square roots. When you're approximating square roots, I would like you guys to think about it this way. Here's your little root line. If you're thinking about 0, and then 1, square root 1, square root 2, square root 3, square root 4, square root 5. I'm going to go on, so I'm going to pause. With all the square root on it. Okay, those are not the integer numbers. So I would like you guys be able to tell me, square root 1 is really 1, square root 4 is 2, square root of 9 is 3, square root of 16 is 4. As you move, what number times what number give you 19? Well, in this case, that's not going to happen, but you guys can probably tell me if we go on to square root 19 and going on to the next one, square root 25 will be the next square root. So square root 19 is between square 16 and square root of 25. But since square root of 19 is closer to square 16, so I probably would say, hey, that's probably going to be 4 point something. Approximately 4 point something. And the number principal square root is rational. Well, this is not rational because it goes on forever. Square root 19 is not a perfect square. And then square root of 169, you can punch in the calculator in. That will actually give you the number 13. So therefore, square root of 169 is rational. Actually have a principal square root. Rational means there's a pattern. So 13 times 13 equals 13, and 13 is a principal square root. Now we are going to do order of operation PEMDAS. Please entertain my dear Aunt Sally with the radicals. So I would like you guys to think about radical in this case is going to be like a parenthesis. So they have a parenthesis priority. So because of that, definitely you can try example 15 and 16 right now. Because those problems does not have any square root. So pause the video, try those problems right now. So the answer for example number 15 is 31, and the answer for example number 16 is 3. Going on to example 17. So let's try the one with a square root. Again, square root is like a parenthesis. Do 3 square root of 2 plus 14 right here, this part first, and that is going to be 16. Take care of your square root first, so that's going to be 3 times 4. What number times what number give you 16? Now, if you cannot remember, there's a way you can break it down. So you can do 16 right here, divide by 2 because it's an even number, that gives you 8. Divide by 2 again, that gives you 4. Divide by 2 again, that gives you 2. Divide by 2 again, that gives you 2. So now you have 1 pair, 2 pair, that's going to be 2 times 2. And that's where your 4 come from. Your final answer will be 12. Example 18. Example 18, please make sure you double check about your square roots. And the square roots, you should be able to punch in the calculator because it looks very complicated. So what we're going to do is you are going to do 47 minus 41. In this case, is going to be just 6. And minus 2 times the square root. Now, I'm going to punch in the calculator and turn it into a fraction, see where I'm going to get. Please pause the video and try number 18. So for number 18 is 0. Please pause the video and try example 19. The answer for example number 19 is 24. And that concludes today's lesson. Thank you so much for watching.